Hello, so in this video, we are going to continue our lesson in simple linear regression. So the next topic is the measures of variation. So we actually have the following terminologies like total sum of squares. It is a measure of variation of the values around their mean. Total variation or total sum of squares is subdivided into explained variation and unexplained variation. So the explained variation or the regression sum of squares represents variation that is explained by the relationship between x and y. And then the next one is the unexplained variation or error sum of squares. It represents the variation due to factors other than relationship between x and y. So where do we use the formula or the measures of variations and regressions? There's a formula, so if you can, or rather if you want to compute for that value, SST or the total sum of squares, so it is just the sum of regression sum of squares and the error sum of squares or SSE. So to compute for SST, you can just follow this formula, and this is computed as the summation of the square of y minus our the mean of the value of y. While for the regression sum of squares or SSR, it is the summation of the square. So we have here y sub I hat, which means the predicted values less the value of the mean. While the error sum of square is SSE, this or the unexplained variations of sum of squares. So to compute for this, so let's go to the Microsoft Excel. So if you still recall, we used this data last time. So let's go to the formula explained here. So what we need to do is to get for the sum of or rather the mean of y. So we also computed this last time. So to compute for this, it is the average because we do not have the word mean here in Microsoft Excel, unlike for other software that they made use of the word mean. Okay, so let's compute for the mean. This is average and close parenthesis. Okay, now next. We have to get the square of y minus the mean. Our y is this one. So y, this is our y, 185 less the value of the mean is this one. So we have to get the square of this. However, since we have a constant value 4292.143 or our mean, then we're going to place a dollar sign here so that we're not going to encode it from time to time or as we go on or drag our data. So let's place a dollar sign, close parenthesis, and then caret 2. Enter. I'll just drag this. Okay, so it is the summation of the y square. So I just, I'll compute for the sum equal to sum, close parenthesis, and get this the value. This value is our SST. Now, if we will get the predicted value, if you used to recall our formula or the formula that we obtained last time using the scattered diagram. So let us generate that again. So insert scattered diagram, and then our objective is just to get the trend line, linear trend line, or the formula for simple linear regression. And okay, so what I need is this value. So I'll encode it here. So equals 8y, or rather we can just copy this. And paste it here. So I'll delete this. I don't need this table or chart rather. So equal sign 83.493 multiplied by the value of x plus 40. What is that value? I wasn't able to make it. Okay, so I'll just place the value first, 48.224. So it's 83.493 multiplied by the value of x. That's it. And then drag it. And then let's go back to our formula. So what we are computing here is the value of the SSR, because the formula for SSR, and so we need the value of our predicted value. So this is the y with caret on. Okay, so what we are going to do is just to limit this maybe into 1 decimal places, just like the original value, or it's limited into, let's change this into 0. Okay. And then, so what we need to do is to compute now for the predicted value minus the value of the mean. So it's already computed. This one, it's 292.143. Close parenthesis. Again, we have to place $sign here because this is a constant to all of the cells from 1 to 14. And then raise 2, so caret 2. And drag it. Okay, so we can again limit this into the desired number of decimal places. So let's place 0, or and then we can just drag this to get the sum. But we do not need this value. What we need is this one. So this is the SSR. So the SSR is 264,368, while the SST is 292,386. So what is next? To get for the value of the SSE, so error sum of square. So let us also compute that part. It is equal to the value of y. So where is our y? This one, less the value of the predicted value. The predicted value is this one, and then get the square of this. The difference raised to 2. And then just drag it and get the, oops, what happened? So let us see. C2 raised to 2. And so let's drag this down. Okay, and get the sum. This is the sum. So you can just drag it, or you can enter the formula again. So this is the SSE. So we have the value of SST, SSR, and SSE. Next, what is the use of these values aside from giving us the idea of variations in the regression? So aside from that, we can also compute the coefficient of determination. So last time, what we computed is the value of the R, and then since we can also compute for the coefficient of determination by just getting the square of the R, then we use that formula. But aside from that formula, you can also use the value by using our SSR and SST. So what is the value of R squared based on this computation? So our R squared is equal to, so let's just substitute the formula, our SSR all over our SST. And so since this is rounded into the nearest whole number, that's why it's 1. But if we're going to look at the value when we see until 4 decimal places, this is 0.942. And for sure, this is also the value that we computed when we generated the value of R squared and when we computed for the value of the R squared. Okay, next. So let us also discuss the standard error of the estimate. So in computing for the standard error of the estimate, this is the formula. So the symbol is S sub yx, which is equal to the square root of SSE all over n minus 2. And then equal to, so since we already have our formula for SSE and also, or rather our computation, so all we need to do to compute for the sy sub x is just to get now the value by substituting it in our formula. So it is equal to, what is the SSE? This is the SSE all over, what is our n? N is the number of data. So we actually have number 14 data. So it's 14 less 2. And then, of course, do not forget to get the square root of the result of this. So it is the square root, open parenthesis, our SSE all over 14 minus 2, and then close parenthesis and close parenthesis. So our standard error of estimate is 48.3190. Okay, so we can actually generate this also using the Microsoft Excel. So last time what we use is the data analysis, or rather what we use is the scatter diagram for us to come up with the formula. So aside from doing that, we can also use data analysis in the in the Microsoft Excel. So you can find data analysis here. So you click the data and there is the data analysis. However, in case that you cannot find this, you need to add in by clicking File, Options, and then Add-ins, locate Analysis Toolpack, and then do not forget to click Excel Add-ins, then go. So just check Analysis Toolpack and then click OK. So the moment you do that procedures and then go back to data, you can already see the data analysis. So let us do the data analysis. So click Data, locate for Regression, click OK. And then let us, of course, when it is your first time to open this, you cannot find the values here. So you need to place your input here. So Y values is, of course, the sales. So you just need to select it. Input is the Y. It is the X, input X. So we will just select this again. I did not select the row 1, so I don't need to place the labels. So we can just set it this way. So I uncheck this first and then click OK. So we have here the values of, as you can see here, 26436, 28016, and the 292384. So comparing it to this value, so let us just summarize. Our SST is 292386. Our SSR is equal to 264368. And so let's bring this back. And the last one is SSE, which is 2802817. I'll copy this and place it in sheet number 2 so that we can see or we can compare it. So our SST as computed here is 292,385.7. So this is just rounded. And then 264368, it is the SSR. There is a regression, residual, and then the total. So as we can see here, you obtain the same answer. So thank you for listening.